So what is an acid? An acid is any substance that will form an aqueous solution with a pH less than 7. So they will form hydrogen ions in water, which will be responsible for the low pH. Some examples of acids are the hydrogen chloride, also sulfuric acid, nitric acid, all of these are acids. So the pH of an acid solution when dissolved in water is less than 7. What about bases? So bases is simply a base is a substance that will neutralize the acid. So bases will react with acids and they will give salts. So the main thing about bases that when they react with acid they will give salts. So what about alkalis? So what is the difference between a base and an alkali? An alkali is still a base, but it's a base that will give OH ion or hydroxide ion in water. So bases don't have to give OH ions in water, but alkalis are a type of base that will give hydroxide ion in water. Some examples of these alkalis are sodium hydroxide, potassium hydroxide, and so on. So they all will give hydroxide ion in water. And also they will react with acids in the same way as bases because they are still bases to give salt and water. So all alkalis are bases, but not all bases are alkalis. There's a reaction that's called neutralization reaction. So a neutralization reaction is a reaction between an acid and a base. So a reaction between an acid and a base to give salt and water is called neutralization reaction. In neutralization reaction, you have a hydrogen ion coming from the acid, hydroxide coming from the alkali to give you the water, and then the other ions will give you the salt. Of course, neutralization, if you use a base, not an alkali, will not give you water necessarily, but will give you a salt. So it will neutralize the acid, the base will neutralize the acid to give you a salt. We can use indicators to show the neutralization is over. So when the pH change or the pH will change until it reaches 7 when the reaction is complete. So you can show that using an indicator. It will change in its color. So let's focus now on acids and see what are the different types of acids. So as we said that acids will produce hydrogen ions in water. Some examples, hydrochloric acid will give you hydrogen ion and chloride ion, nitric acid, hydrogen ion and nitrate anion, and sulfuric acid will give you the hydrogen ion and the sulfate anion. So there are two types of acids. One type is called the strong acid and the other one is called the weak acid. So what is the difference between these two? Strong acids examples of strong acids are hydrochloric acid, nitric acid, and sulfuric acid. These strong acid will ionize completely in aqueous solution to give you the hydrogen ion and the other anion. However, the other type, which is called weak acids, and weak acids, examples of these are organic acids like ethanoic acid and citric acid. Also, carbonic acid is one of the weak acids. The difference here is that weak acids will not fully ionize in water. They will only be partially ionized and they will release hydrogen ion in the same way as the strong acids, but not completely. So this is a process called reversible reaction. In the reversible reaction, for something like ethanoic acid, the reaction will start with the ionization of the ethanoic acid in water to give the anion and to give the hydrogen ion. Once these two are formed, they will react together in a reversible reaction, backward reaction, to give you the intact acid again. So the reaction will keep going back and forth until we reach a point of um, we reach the until the hydrogen ion concentration stays constant. And then we have reached what we call the equilibrium. At equilibrium, the rate of the reaction, the forward reaction, will equal the rate of the backward reaction. Normally, reversible reaction, we use these two arrows back and forth, which indicates the back and forth reactions happening at the same time. So these are called weak acids. So what about the acids and the pH? So a pH is a measure of the hydrogen ion concentration in a solution. So for every 1 unit decrease in the pH, that means that there is an increase in the concentration of hydrogen ion by a factor of 10. For example, if you have a solution with pH 3, for example, and then um, and then you have another solution of pH 2, then the pH 2 means that the concentration of the hydrogen ion has increased by 10 times, by a factor of 10, because there is a change in the pH by one value. The factor in general, the factor of hydrogen ion concentration for any solution will change by a factor of 10 to the power x, where x here refers to the difference in the pH between the two solutions. So, for example, if we change the pH from 5 to 2, that means the hydrogen ion concentration will change by a factor of 10 to the power 3, which is basically 1,000. The pH of strong acid is much lower than the pH of a weak acid if they both have the same concentration. So focus with me on this sentence, if they have the same concentration, because that will bring us to discuss the difference between strong acid and concentrated acid. So concentration is different from the strengths. So there is something called acid strength, which refers to whether the acid is strong or weak, which means the proportion, or refers to the proportion of the acid that dissociate or ionize in water. That will give us either a strong acid or a weak acid, while we also have what is called the concentration of the acid. That will give us either concentrated acid or diluted acid. The concentration of an acid is a measure of how much of the acid is there in a certain volume of solution. So acids can be strong and dilute, or they can be strong and concentrated. They can also be weak and dilute, or weak and concentrated. The pH of any acid will increase, the pH will decrease if the concentration of the acid increases, whether it's a weak or strong acid. So if you have a weak acid or a strong acid and you increase the concentration, then the pH will decrease because the hydrogen ion concentration in the solution will increase. Now moving on to talk about bases. So we said there are bases and there are alkalis. All alkalis are bases, but not all bases are alkali. So what are the examples of alkalis? So water-soluble metal hydroxides and metal hydroxides are alkalis because they dissolve in water to give you hydroxide ion. These bases will react with acids in a neutralization reaction to give you salt and water. So even insoluble metal oxides and metal hydroxides will still neutralize the acid to give you salt and water. However, insoluble metal oxides and metal hydroxides are not considered to be alkali. The main reason for that they are insoluble in water, which means when they are added to water, they will not give you the hydroxide ion, but they will still react with acid in a neutralization reaction to give you the salt and water. Some examples of these are the reaction between hydrochloric acid and carbon and copper oxide to give you copper chloride and water. Also, we have hydrochloric acid with sodium hydroxide will give you sodium chloride and water. If you move on to something like sulfuric acid with zinc oxide, will give you zinc sulfate, which is the salt and water and so on. So you can apply this to any acid with either metal oxide or metal hydroxide. So another important thing you need to know is that non-metal oxides are acidic. So what are the non-metal oxides? Non-metal oxides, something like sulfur dioxide or nitrogen oxide. These are acidic and these are not basic like the metal oxides. So metal oxides are basic, but but non-metal oxides are acidic. The main reason for that, when they dissolve in water, they give you acids. So like nitrogen oxide with water will give you nitric acid, which will then give you the hydrogen ion and the nitrate. Same thing here for sulfur oxides. When they dissolve in water, they will also give you acids. So non-metal oxides are acidic, not basic. Another example of bases which are not alkali are the metal carbonate. So metal carbonate will react with acids to give you salt, water, and carbon dioxide. So example is hydrochloric acid with sodium carbonate that will give you sodium chloride, water, and carbon dioxide. Also sulfuric acid with calcium carbonate will give you calcium sulfate, water,